Hey everybody, you want to learn how to solve quadratic equations? It's this simple. Remember, you want to get these into standard form for a quadratic equation where it has ax squared plus bx plus c equals 0, where each of these terms are in descending powers of the variable. Does everybody understand? Yeah, see these numbers next to each of these terms for x squared a, number next to x is b, and the number over here is c. So, if you want to solve this quadratic equation, do you have 0 on one side? No. See, if you don't have a happy 0 on one side of the equation, you can't solve it. So what are you going to do? You're going to move everything to the side that has x squared on it. Alright, so let's see what happens. If you subtract 4 over here, and then you get a new equation. See the 4's go away? Yeah, happy 0. Okay, so then you have the 6x squared term. Remember, you're writing this in descending powers of the variable, plus 5x minus 4 equals 0. Now, how on earth do you solve these? You can use the quadratic formula, the opposite of b plus y square root of b squared minus 4ac, all over 2a. See how beautiful that is? That's so wonderful. Or you can solve this by factoring by grouping. You want to see how to do each one? Of course you do. That's why everybody's here today. So let's imagine that you use this formula. Well, the a number is 6. You see that? That's the number next to x squared. And then the b is the number next to x. That's the positive 5. And c is the negative 4. That's the constant term. That's the term without any variables in it. Alright, so you can take the opposite of b. You can add negative 5 plus or minus the square root. And then you've got to take b squared. See how I'm substituting these into the problem with your parentheses? See, when you substitute these values for these variables into the quadratic formula with parentheses, it makes a big deal, because that way you do all the order of operations correctly and you get all the right answers. Isn't that great? Okay, so this is what's going to happen now. You got this, which is the opposite of b, which is negative 5. Does everybody agree? And 2 times that is 12. Everybody see? It's beautiful, right? Now this is where it gets yucky. You see the square root of all this junk? You got to do this separately. So you're going to do b squared. You're going to do the exponent. Then you're going to multiply 3 numbers together. 4 times 6, 24 times negative 4 is negative 96. So you're going to take 25 minus negative 96. That means you're going to add 96 to that. It's 121. The square root of 121, 11. Ding, 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 ding. Okay, so then you get to take negative 5 plus 11 divided by 12, and then negative 5 minus 11 divided by 12. Does everybody see? And then you get 6 twelfths for 1/2, because the numerator and denominator both have a 6 in common, so you can reduce that to 1/2. Or you can subtract them and get negative 16 over 12, and then if you divide both of these by 4, you get negative 4/3, which is also the equivalent of negative 1 1/3 for those of you who do not like improper fractions. 1/2 and negative 1 1/3. What do you think of that? And now you can solve this by using factoring by grouping if you didn't like that way. Or you can even check your answers. You can check your answers. Alright, so if you take 1/2 and you plug it into the problem, the original problem, we're talking about that bad boy right there. If you put this 1/2 into the problem, is this a true statement? Let's see. 1/2 times 1/2 is 1/4. Times 6 is 1 1/2. And then 5 times 1 1/2, 5 times 1/2 is 2 1/2. Because it's 5 over 2. Remember, you're multiplying numerators and denominators together? And that's the same as 2 1/2, and 1 1/2 plus 2 1/2 is 4. Yeah! And then negative 1/3, 1 1/3. Let's try that one. If you put negative 1 1/3 into this equation, are we going to have a true statement? Who knows? Who knows? Alright, so let's try this. Negative 1 1/3. Why is this happening to me? Okay, great. I mean, this is the same as negative 4 over 3. When you multiply negative 4 over 3 by negative 4 over 3, you get 16 over 9. Alright, so you have 6 times 16 over 9, and that can cause cancel, so you get 2/3. So you're left with 32/3. That's great, isn't it? And then over here, if you take this 5 and multiply it by negative 1 1/3, you get 5 times negative 4 over 3. And then if you multiply numerators and denominators together, you get negative 20 over 3. So you're going to add these together, and since these are like fractions, you can add the shirts. If the pants are the same, you can add the shirts on the fractions. And then you get 12 over 3, and that equals 4 too. Ding, 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 ding. Those are the two solutions to this quadratic equation. What if you didn't like solving it that way? Well, you can do this another way. You can use factoring by grouping. Ew! How do you do factoring by grouping? You take the a times the c. So a times c there is negative 24. Everybody see how I did that? That's great. And then you're going to find 2 factors of this negative number 24. 2 factors of 24 that are 5 apart. What factors are 24 or 5 apart? Well, you got here choices. 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Ding! 3 times 8. Which one's going to get the plus sign? The bigger number. The bigger number has to have the positive sign. Remember, the product of two numbers with different signs has to be a negative, so one of these has to have a different sign. So if we pretend that the middle term has 2 parts instead of 1, we can actually split this. We can change this into 6x squared minus 3x plus 8x minus 4 equals 0. So we see how I changed the middle term into 2 separate pieces here? That's great. And then you split this into, you find the greatest common factor for these 2 terms. The first 2 terms, that's 3x. And when you divide each of these terms by 3x, you get 2x minus 1. And then when you divide those by 4, you get 4. And then that's the greatest common factor. And then when you divide them by 4, you get 2x minus 1 again. These are the common binomial. So then you put those together. You can put the outsiders together. Those are the tag team of the greatest common factors next to the common binomial. Isn't this nice? Now wait a minute. How do you get these answers? It's easy. Because you have the zero product property, the product of these two is equal to 0. So either this is equal to 0 or this is equal to 0. So if 3x plus 4 equals 0, you subtract the 4 and you divide by the 3, ding, you get the same exact answer we got moments ago. Negative 1 1/3. How about that? And then if you have this factor, 2x minus 1 equals 0, and you add the 1, and you divide by 2, you get ding, 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 you get 1/2. How about that? So solving quadratic equations involves some steps. You gotta make sure you write this in standard form where everything is on one side equal to 0. That might mean you have to manipulate some things. Sometimes it's easier to move everything to the same side where x squared is. Then you have choices. You can use the quadratic formula, you can use factoring by grouping, or you can use another technique of your choice. Isn't that great? And then everything else is pretty self-explanatory. Use the order of operations to break down this part of the problem using the quadratic formula. Here, you have to find a way to split the middle term using 2 new terms, so that way you can break this into half. And then you can factor by grouping. So that way you can find what the greatest common factor is of the first terms, the second terms, put those 2 together, you find the common binomial, and set each of these equal to 0. And then you can get both answers and check to see if they're right. Do you like math? I do, and I'm not even Kermit, but I did it in a Kermit voice anyway.